Okay, folks, on to 4.7. So they give us problem number 280. 3x plus y greater than 5. 2x minus y less than or equal to 10. And we want to see if 3, negative 3 is a solution. So if we plug in 3 for x and negative 3 for y, will this statement hold true? And will this statement hold true? If yes for both, then this would be a solution. So let's plug in 3. So 3 times 3 plus negative 3. Is that greater than 5? So that's 9 minus 3, which is 6, greater than 5. Yes. Okay, let's try the next one. So 2x is 3. Minus y, negative 3. Is that less than 10? 6 minus minus is plus. Is that less than 10? Is 9 less than or equal to 10? That holds true. So that means 3, negative 3 is a solution. Yes. So yes, it's a solution. Okay. And then part B says, hey, why don't you play the same game, but with the numbers 7 and 1. 7 and 1. Okay. So 3 times 7 plus 1. Is that greater than 5? 21 plus 1. That's 22. Is that greater than 5? Yes. Okay. Let's try the next one. 2 times 7 minus 1. Is that less than 10? 14 minus 1. Is that less than 10? Is 13 less than or equal to 10? What? No, 13 is more than 10, so no. So 7 comma 1, not a solution. Aha! Okay. So plug in some numbers, and then it gets fun. So I like this section. I like things that can be done really quickly. So in this section, it's just graphing and shading like we were doing before, and then you just double shade the region that gets shaded twice, so it's kind of fun. So in 286, we have y less than or equal to 3x plus 2. And then I guess I will use, let's see if this one works, y greater than x minus 1. Okay, so let's graph these. Y in the sky, that's my x. So the first one, go to positive 2. Positive 2, put a dot. How do I get to the next dot? Slope of 3, so call 3 over 1. If you have graph paper, that'd be a lot cooler. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. And solid line. Okay. And we want y values less than. So if you're thinking vertically, you can either be above the line or below the line. We want y values less than. So I'm going to shade below the line. Hopefully you're okay with how I'm shading it like that. Below the line. Below the line. Okay, now in the pink here we have y greater than x minus 1. So go to minus 1. Put a dot. That's your y-intercept. Slope of, there's nothing there, but it's technically a 1. It's technically a 1 over 1. Up 1 over 1. Up 1 over 1. Oy vey. So draw this a little bit further. So this greater than, but it's not greater than or equal to, so it should be a dashed line. And they actually sort of do intersect. My picture is horrible, but if I had graph paper, it'd look really good. And we need y values greater than, so on this side of the dashed line. Okay, so now we have to see where do they overlap. Where do these things overlap? Below the solid black line, above the dashed purple line. It's going to be everything in between there. And that's my answer, that double shaded region. See? Fun. Okay. So they're all basically like that. So maybe they don't give it to you in y equals mx plus b form. No big deal. Let's do 298. So we know how to graph, we know how to shade. We're just looking for the area that gets double shaded. X minus 2, y less than 3, y less than equal 1. Okay, let's focus on this top thing here. I'm going to bring the x over. So this becomes negative 2y less than minus x plus 3. I just subtracted x from both sides. Okay, divide everyone by negative 2, negative 2, negative 2. Uh-oh, if you divide by a negative 2, if you divide by a negative, switch the inequality. So y is greater than 1/2 x minus 3/2. Let's graph that here in black ink. So go to negative 3/2. So negative 1, negative 2, it's right in between. Put a dot. Slope of 1/2, up 1 over 2. So up 1 over 2, up 1 over 2, and it's a dashed line. If you have graph paper, it'd be a lot cooler. Okay, and now we want to shade to see which side. Y values greater than, so everything on this side of that dashed line. And now in pink, y less than or equal to 1. Ooh, it's kind of in y equals mx plus b form, right? So it's basically y is less than or equal to 0x plus 1. So the slope is 0, which is a flat horizontal line. So at 1, and it's solid, so less than or equal, so I'm going to put a solid line, like so. And we want y values less than, so below that pink line, or red or maroon, whatever it is. It's dying. I need new pens. Okay. And now we need to figure out what area got double shaded. What is true for both of them? This little wedge area right here. That goes on forever and ever. Ah, and that is our answer. That whole area is our answer. Okay, see? These are fun. Yeah, that's basically the game. So you should be able to handle 4.7.